Often in the IGCSE there are keywords that can give you a hint in terms of how to approach a question. This is one of those. This question involves asking you to find the maximum value of a volume, and therefore we're going to be using differentiation to actually find our solution. So we have here the radius of a right circular cylinder is x, and the height is given by that expression just here. I'm just going to draw a sketch. You wouldn't need to do this in the exam, but I think it's useful to actually visualize exactly what is going on here. So we have a cylinder like this. The radius is x, and the height is going to be 800 over pi x minus x. That's a hideous looking expression. And the volume is V. And it says find the maximum value of V, the maximum volume. Well, we should know that the volume of the cylinder is. We're given that expression or that equation in the exam paper. So we know that volume is equal to pi r squared h. So our V, which is our volume, is equal to pi multiplied by the radius, which is x in this case, x squared, multiplied by h, which is this horrible expression here, 800 over pi x minus x. Probably worth tidying this up a little bit. So what have we got here? We have V equals, we have pi x squared multiplied by 800 over pi x minus pi x squared multiplied by x. Well, the second part of that is quite nice because that just gives us pi x cubed. That's easy. The first part, you can see that the pi's will cancel, and one of the x's will also cancel as well. So we end up just with 800x. So the volume is actually a lot nicer to look at than the expression for the height. Now, we're looking for the maximum. So therefore, what we will do is we will have to differentiate. So normally you would differentiate dy by dx. Because we're doing volume here, it's going to be dv by dx, but it works exactly the same way. Now we have our expression here written in index form, so there's no fractions here, which makes the differentiation nicer. If we differentiate 800x, we just get 800. And if we differentiate minus pi x cubed, the 3 comes to the front of the minus pi, so it's minus 3 pi x squared. Take 1 off the power. So that's our expression then for dv by dx. And we want to find the maximum, so we would put that equal to 0. So we would write an expression of 0 equals 800 minus 3 pi x squared. So let's take that one up to here. Let's rearrange that slightly. So we're going to get 3 pi x squared is equal to 800. So x squared is equal to 800 over 3 pi, and x will be equal to the square root of that. So the square root of 800 over 3 pi. And when you work that into a calculator, x will come out to be 9.21, and then a whole bunch of decimals. That's the value of x when we have the maximum value of v. So the final step here is you have to take the value of x here and put it into our equation for the volume. And this is probably the easiest form of the equation for the volume. So this is the one I'm going to use. So my volume, I'm going to call it volume max, is equal to 800 multiplied by 9.21. Take away pi multiplied by 9.21 cubed. You put that into a calculator and your maximum volume is 4913.69, and so on. We are asked to do to the nearest whole number. So Vmax is equal to 4914, because the 6 here tells us that we round the 3 up. So it's 4914 centimeters cubed.